Hello, welcome to another episode of Data in the Hallway. My name is Ray Pate, Community Manager at for TiDB. Here with my colleague Daniel, joining us from the Netherlands. Hi, Daniel.
Hello.
And we're joined by another one of our colleagues, Sam Dillard. I mean, this is your third appearance on our podcast, so like you deserve some sort of a medal. I mean, thanks for coming us on, and glad to see that we haven't scared you away from appearing on our podcast. So welcome back, Sam.
Thank you. I'm glad I haven't scared you from inviting me on. So
Uh, it's good to have you back, and I'm sure this won't be the last either. So, yeah. So the topic of the conversation, everyone talks about like a Gen AI and RAG, and the title is the backbone of RAG is basically like you know data and structured data in particular. So that's a theme, and let's like level set here. I think what happens with a lot of these uh, hyped up topic is that people use a term all the time, but people don't necessarily like understand it, or I mean they may think they understand it, but their understanding's not doesn't go beyond like a surface level. So. I mean, Sam, you talk to our customers and users all the time, and I'm sure this topic comes up. Like, how do you explain like RAG to the customers that you talk to?
yeah, I mean, we get this question about how TiDB plays a role in AI applications, and you know, I'm left thinking like, well, it plays a role like it plays a role in other applications that are not AI. But the way I frame it is because I think sometimes you do have to kind of meet people where they are. If they're not really familiar with applying a database to an AI application, you got to kind of walk them through it. Um, a an AI application is really just a standard application that makes use of AI in some way, right? I know that sounds really straightforward, but and it is that straightforward. And the most common way that applications I think are implementing AI is in the form of RAG, retrieval augmented generation, which is kind of at this point in AI years is fairly old hat, but still going strong. And that's where databases are a really crucial part. These AI applications that do retrieval augmented generation, what this is essentially just adding knowledge, some sort of knowledge base, facts, data, numbers, string, text, whatever it is, that the AI, or in most cases it's an LLM, a large language model, that the pre-training of that large language model didn't have access to. So everyone who's listening to this probably already knows what I'm talking about, but if they don't, like they at least know what it's like to get an answer back from an LLM that is not satisfactory or just totally hallucinates, right? Like the hallucination meaning that it answers the question with conviction and is totally wrong. And it's kind of hilarious. It's worse than even the most arrogant human might do. Um, so or with the most hubris. So RAG is for basically augmenting the LLM or augmenting the prompt to the LLM or prompts so that you can provide it more context. You can and that context can take the many forms. We can talk about this um, down the road here, but basically at a high level, it's stuff that's either new to the world, like real time stuff that wasn't available when the model was trained. So, real time information is good context, or private information. Private information is information that like enterprises have that you just legally or contractually or policy wise cannot give to an LLM. So you have to, or you can't train it on. So you have to give it in the prompt in real time and that stuff. So that's RAG is really about just improving the responses from lots of standpoints from the LLM.
Cool, cool. No, thanks for the context. And like I said, I think it's helpful to sort of kind of level set on the main topic here. I obviously follow you on LinkedIn, and you made an interesting post a couple of weeks ago about there's this like talk about RAG is dead, which is kind of interesting. I mean, you see that with a lot of topics all the time. Like something new comes along, and pretty soon, like 2 months later, they say XYZ is dead, right? That's kind of predictable. So yeah, I mean, for people who don't follow you on LinkedIn or haven't seen that post, like, talk to us a little bit about that. Like, why is there this sentiment that RAG is dead? And obviously, you made a post because it's not true. So I'll let you like to jump in here.
People love that phrase, something is dead. It really catches the eye and it gets clicks, and we're kind of in a click economy, as they say. I mean, we have been for a while, but it's not less true now. Um, Rag is dead it's not pervasive, but I'm trying to prevent it from being pervasive because it's totally not true. The reason why somebody might have said that is, and I think the context that I read it when I was triggered to write the post was in the context of agentic AI, which is a whole other, term that I can define, but agentic AI is basically, really, long story short, like creating application made up of other applications that do that access AI models, right? And for whatever reason, I mean to be vague because it is an unbounded category, unbounded space of use cases. But it's tool use and it's like calls to different sort of more specific functions that use AI, and that create kind of a larger whole. And one of the arguments I've heard made is that in agentic AI, the agents can replace the RAG semantics. They're sort of going to get the context from a database and then putting that into a prompt to a model. And there's actually just so much wrong with that sentiment. I probably won't go into it in depth here. I could do a whole episode on it. It's true in some sense, like you can replace some of RAG with agentic AI but then you introduce latency and it's kind of ugly. Um, so I would say that that argument is fairly feeble. Um, but in general, RAG is not only not dead, it's literally required for the reasons that I already gave. Kind of, it's um, these models are not training on real-time data, and they're by definition, enterprises all have information that they can't share in training, and that they need to go get for adding context, or providing context to the LLM, and that's text documents, which are like kind of the
Hmm.
most common, or at least the first renditions of RAG. And then it's also like your standard structured data. Like we'll talk about that more, but all data that an enterprise has or that an app sits underneath an application is potentially context for a model that's obviously not going to be part of the training of that model. So for any use case that requires that information, RAG is required, some form of RAG. And it always will be. That's never going to change. So RAG is
It's
alive.
it's also for a more personalized response, right?
Yeah, yeah. I mean, it's the providing the context of like your private data that the LLM doesn't have in its weights, um, is really important for honing the type of answer. The other thing too, and this is related, is um, LLMs by definition, to be conversational, they have to be trained in general. They have to be lowest common denominator. They're probabilistic models, so they're going to give you, depending on temperature that you set it at, they're going to give you the most probable answer based on what they've learned from their corpus, which is generally the internet and other texts. If your enterprise has a need to kind of override that, right? Like certain words and certain phrases mean something different inside of your company in your own contexts. The LLM is going to give you the wrong answer every time. So you do need to override that with internal context.
Cool. Yeah, I mean, thanks for the that context, and obviously, I mean, you made a good argument as to why. I mean, RAG is not only here to stay, but it's almost to a point where it's irreplaceable, right? I mean, if you don't have RAG, then I think both you and Daniel pointed out to situations where it just won't give you a satisfactory answer to whatever questions that you're asking. And
Yeah.
I think the other thing that people throw around is there are other ways to sort of get around like RAG. But I think you know, I think already pointed out why that just can't be the case. It's almost a requirement to have if you want to have a good like an AI system to help solve whatever business problem or technical problem that you're trying to resolve. So cool.
Yep.
Cool. And then I think you already talked about this. I mean, we talked about like data for to complement or to supplement like the generic LLMs. You need to provide either real time or private data. So data is something that you need. So let's sort of like talk a little bit more about what kind of like a data or information do you need to provide for a good RAG based system?
Yeah, I think that's the other part of like the answer to the that I would, yeah, I would, if somebody were to ask me like what role we play, I'd have to
Mhm,
dive more into the type of data for sure. And
mhm,
as when RAG first came out or was kind of first implemented, I think I don't know if it's the first implementations necessarily, but it's what got famous at first, and that's text-based applications, chat bots and things like that, where the context is the chat context, or just answering questions about enterprise documents. ChatGPT just integrated with Box, so I see Aaron Levy posting about this on LinkedIn, and I think it's really cool. Really exciting. I mean, Box is a secure file sharing system, so it's by definition the documents that you're going to be storing there are probably going to be private, and the ChatGPT will just reach out to Box and find the documents that it needs, but using Box's system, Box's searching, and then return you the right documents, and then it would feed that into the prompt to the LLM, and then give you back a better response. That makes ChatGPT actually kind of a RAG app, in fact. But um, that's a very traditional use case. That's a traditional RAG. It's using text documents, chunks of text documents to go out and search for relevant things. But there's a whole other world where any application data you have could possibly be context for an LLM or for a prompt. And I think there's tons of ways that this can be manifest. The most the most immediately obvious ones are just, and this is actually something that's available in vector databases themselves, but metadata about the text. So you can have about a document, you can have author name, title, created date, last modified date, published date, whatever that is. You can have length, you know, topic, even if it's different than title, subtitle, whatever it is. You get it. The metadata. You can do queries on that, like I want to find all the relevant documents to this search query, but only give me the documents that are of the last 3 months, last modified in the last 3 months. And that is metadata you need to search on, and you need database searching to do that. Vector DBs typically allow you to do at least that kind of filtering. But it starts to get way more complicated when you introduce relational semantics and like joins, and you want to start doing ad hoc index creation so that you can speed up queries on all sorts of different columns, composite indexing so that the even your primary key search is faster. Um, there's a lot of reasons to use, like there's just, you have to think about databases the way you traditionally have, to support these RAG applications. Nothing has really changed other than some of the framing.
cool, cool. Yeah, so I mean, you mentioned like vector database, and I think this came when we did about as we're recording this almost about a year ago, we did our hackathon sort of featuring the new vector search feature of TiDB, and people were already building like interesting RAG applications during the hackathon, which was kind of nice to see. So I'm sure this discussion comes up, and you and you mentioned this already, like when you talk to customers or even prospects about TiDB, you know, this is somewhat self-serving because we're all involved in the community. But what are some of the things that TiDB like it brings to the table as people are building their AI applications or even like a RAG-based applications for their enterprise.
Yeah, I mean, I'll answer that in two parts because there's two
Yeah,
topics in there.
yeah,
In those hackathons, we saw a lot of creative stuff. In the earliest, I think in 2020, early 2023, I think. I'm trying to remember when ChatGPT originally came out. I think it was late 2022. Um, I might be wrong about that,
yeah. Let me
but
look that up. But
yeah, early 2023, I think. TiDB or PingCAP, we introduced a chat to query functionality, which was, um, it made use of translating SQL or translating natural language into SQL. And then not long after that, we introduced our own publicly facing smart chatbot related to TiDB so that customers and even people internally could get help on TiDB specific things. And it was, um, there may have been some fine tuning involved, but actually most of it is RAG, where the RAG was using our documentation and other internal documents, potentially like cases and things like that, to provide the LLM context to answer questions better. Because Google or like ChatGPT are not going to answer these questions at all. So TiDB.ai is the publicly facing version of that. And anyone who's listening to this can go check that out. That one is actually really interesting. You'll notice that it's a little bit slower than ChatGPT would be. Partially that's just because it hasn't been optimized super well. It's just kind of a side project for the group. But the main reason is that it's using another form of RAG called graph RAG, which is an architecture that was, I think, introduced mainly by Microsoft, the Microsoft team. And GraphRag is the idea that the searching that you're doing before you do any vector search is a graph walk of trying to find the relationships between parts of text or between documents. So um, I can go into this in a second too, but like GraphRag solves problems that traditional RAG doesn't at all, that traditional vector search doesn't at all. And that's kind of the thing is like RAG is also a big category. So you can have modifications of traditional RAG like GraphRag to really, really make answers to questions so much better. And so TiDB is an example of that. When you ask it a question, it even kind of shows you, it gives you visibility into that graph process where it's creating a graph, and it kind of shows you a little bit of what it's doing under the hood for anyone who's curious.
Yeah, and I think that TiDB.ai is a very useful tool for like many people just wanting a quick answer to a simple question, and just slightly more than like just searching our documentation or Google provides.
Yep.
yeah, I mean,
I'll just
no, go ahead, Sam.
well, just to add on to that, I'll just go into the part the detail I deferred. The traditional RAG, right, is doing vector search, some sort of vector distancing to match your traditional filter that you would do like for a number or some sort of text field or a date, is doing that, but using like cosine distancing or some other distancing calculation. And that is super useful. It's probably one of, if not the best ways we have today of finding relevant texts to a query, but it's entirely useless in some cases where this is a very common example, but let's say we want to ask our application, who was the most recent company acquired by OpenAI? These questions that start with like who or which, these open-ended questions, they don't come with the name that you want to actually respond back with, right? So the query text doesn't include the context that you need to answer the question. I mean, it includes some of it, the cursory stuff, but the answer to the question is not contained in the query at all. Like there's nothing about the query that directs the search for that answer. So the answer in this case, I think when this question was introduced originally to the public, the answer was looped, LOOPT, an acquisition in 2023. But the answer today is, unless this has changed and there's something more recent, is Windsurf, the competitor to Cursor as a AI IDE. And that's a marquee acquisition. Obviously, your LLM, if it's not updated on that information, is not going to know that. It's going to not know, or it's going to just hallucinate a different answer, or it's going to give you the previous answer like looped, right?
Hmm.
And that's just wrong. So you have to give it the right context. But asking who was the company that it acquired doesn't necessarily get you there, right? You're gonna start vector searching on things related to OpenAI, things related to acquisitions, and some sort of merging of the two concepts. But nothing about that is directing your search to windsurf. You might get lucky and you might get the answer, but you probably won't. And so graph does a graph walk first, where it finds you've used an LLM to actually to create the graph, but you have entities and relationships or vertices and edges or nodes and edges that can be identified by the LLM at query time. So when you say who did OpenAI most recently acquire, you have OpenAI as an entity, right? And then you can search OpenAI, and then the relationship is acquisition or acquire. You walk down the graph for OpenAI related things. You search on this relationship um, the similarities and relationship of acquisition, and then you find one, two, three or so steps away from OpenAI this story that was the acquisition of Windsurf, and then that data gets fed back to the LLM to synthesize a response, and that's how you get your answer, and that's what you see in TiDB.ai, and that's what you see in a lot of more sophisticated RAG applications that are trying to close the gap on how accurate or how inaccurate their answers are.
Cool. Yeah. I mean, yeah. I mean, TiDB AI obviously is a great example, and sort of, using that as to sort of walk through uh, how like AI or RAG is developing over the past couple of years. It's I think it's a great way to sort of demonstrate like the progress we made. And I just looked it up. ChatGPT was actually released in November 30th, 2022.
Yeah.
So almost, I mean, it's almost like 2023. So I think you're right on there, Sam. So cool. And yeah, I mean, obviously we talked about what a RAG is, and then why, and we also talked about your posts, kind of refuting some people's notion that RAG is dead, which is kind of a nice clickbait, but I think we heard good explanation as to why that isn't the case, and the role that TiDB can play for a lot of people that are trying to develop a good RAG applications. So what are some of the challenges that exist today for building a RAG applications? And when you talk to customers, people out there that are using TiDB, it's like, what are some of the challenges that the hard problems that people are trying to tackle?
Yeah, I mean, um,
I know that's a difficult
I think
question, but yeah.
one of there's sort of two that come to mind. One
Mhm.
is obviously the accuracy thing. So like
Mhm.
general RAG is really like doesn't just totally flops on certain types of questions by like sort of by definition. Then I walked through that, but the other thing is probably performance. And
Mhm.
part of like my answer to the why RAG isn't dead is that agentic AI is not really going to replace it. Um, Agentic AI use doing like database search to find that context with an agent against another application is far too high up the stack, right?
Mhm.
That's not going to get you the latency SLAs that you want in your application. So databases are still going to need to be the place that you go looking for that context. Um, Agentic AI is for gluing together integrations and things like that in a lot of
Right.
cases. But um, I think that performance thing is a really big one that is maybe we're a little early for talking about
Mhm.
this kind of optimization, but maybe I'll just go on the record saying it today and we can refer back to this. But
Yeah.
um, there are there's a couple things that people are that really get overlooked on this stuff today, and potentially even in the distant future, it will be overlooked by some. And that is the stuff that we think about anyways with database semantics or with any application that uses database. And that is like the benefits and costs of using like an SQL database, for instance, or no SQL or some other form. And when you're thinking of your application, even if it's RAG or graph RAG or GNN RAG, another type of RAG, it, there's still the same requirements you had before, probably, depending on the app, of filtering by all sorts of things, grouping by things, joining. Like if you want to normalize, as far as database terms are concerned, normalizing your data is an efficient way to store application data, and it uses a lot less storage space to do it. Um, Being able to join, once you do that, being able to join data across different tables is really, really important. But the other thing that's really overlooked is that SQL is a declarative query language. There's a reason why it's so popular. Every developer understands it. There's a reason why even no SQL databases all support SQL, or pretty much most of them do. And it being declarative, one of the benefits is obviously that it's kind of easy to wrap your mind around and think about and learn, but it gives the developers of the database itself the power to decide how the query gets executed, because the developer doesn't necessarily know. So SQL databases come with a query optimizer built in. And that has, these are database experts. These are linear algebra people who really understand relational algebra, people who understand these models such that they can execute the query super fast. If you have a GraphQL database you're leaving the developers to decide how the thing gets executed, and that's not always the best way to do it. And so with SQL, you have this query engine that's aware of the vectors that you have there and the structured data that you have, and exactly kind of which to filter by first, which to join on first. If you're going to join on join one table to two other tables, what the order of that joining is, what type of join it'll do, that kind of stuff, and under the hood. And that is really, really important for application performance. It's just probably something that people aren't ready to think about yet. So I just, want to put it out there. But that's certainly going to be a reason that a lot of people are replacing their vector databases in the near future, or, in a couple of years.
Cool. Yeah. I mean, when I threw that question at you, my guess was, performance would be one of the challenges, and it always is, right? When you're a database users, and I think it's more so the case with AI applications, because even just like internal documents, like even if it's just a simple text-based document, you could be talking about hundreds of thousands of like documents that you need to feed, right? Which is no mean feat, but so a lot of
Yeah,
information to sort of sort through. But
that's the challenge that
yeah.
you're right. And that's actually the biggest challenge that I think is you're right. Speaking of overlooking, I overlooked that. The one of the things that you have a problem with in RAG applications is, well, in AI applications in general, let's just take RAG out for a second, is that this context continues to grow. The knowledge base continues to grow. So when you go out looking for context, if there's no way to pare that context down in some way, then essentially, almost by definition again, you're including all or at least an increasing amount of context into your prompts. And we all know that there are not only context window lengths limitations on each LLM for good reason, but even when you come in under that length and your request succeeds, you're paying for the tokens. You're paying for how big that context is. You're paying for it on the input. You're paying for the response on the output. And the responses are usually longer if they're taking in more. It's not always the case, but there's a good correlation there. So you're just paying a lot more money, and it's also just worse for the environment. We all know the power that these data centers use on inference. So you're kind of not doing your part, right? But the thing that's going to resonate with everyone is cost, for sure. Cost in dollars and in time, because that inference also takes longer. You might notice if you're on ChatGPT or something, and you've got a long thread going, you might start seeing some lag. The responses would take a little longer because it's feeding in the entire context window, the entire context of your conversation every time, and then it's also kind of like looping that back and forth through the end. I mean, there's optimizations to prevent that now, but like fundamentally, that's kind of what's happening. So it's just really important to be able to pare that down. And what we're talking about today in RAG is like different forms of paring down that information. So in vector databases, the paring down, the whittling down of your context, filtering for the best answers or best context to use in the answer is vector distancing. That's the form of filtering down the context. In a system like TiDB, for instance, where vector is supported, but also relational semantics are supported, it's just one way. So you can pare that down on a specific column, but there's other columns and indexes on those columns where you might be able to pare down again by date, creation date, or it might be able to pare down by the name of the author or topic or whatever else, right? And in the case of graph rag, you're paring it down by doing a graph walk. You're finding the related documents that are kind of degrees of separation. They have degrees of separation apart from each other. They're not like immediately retrievable by vector distancing. And that can be implemented in relational databases as well using a specific schema and joins, right? Joining different tables to each other. So long story short is that the one big challenge is certainly the context length problem.
Cool. Awesome. All right. Go ahead, Daniel.
Oh, sorry. I didn't have any
All right.
questions.
No worries. So I thought you were about to jump in. Well, thanks for the tour, Sam. And then maybe we'll have you back and talk about whatever the next thing is that in the AI land in about 6 months. But
I'm the
cool.
reanimator.
Yeah, there you go. There you go. And then we talked a lot about TiDB.ai. I'll definitely add a link in our episode description. And then you don't even have to go to the site. If you're in a Slack community, when you go to the help forum, you'll see a lot of people invoking TiDB AI Assistant. And that's, you'll get to experience TiDB AI through that as well on our Slack channel. So cool. Well, Sam, thanks for coming on again, and we look forward to having you back soon.
You bet.
All
Thanks,
right.
Ray. Thanks, Daniel.
Cheers. Thanks.
Take care.
Thank you.